Today we will practice solving single variable inequalities in one step using addition, subtraction, multiplication, or division. So let's get started. In this first problem, 9 is added to our variable. So using the concept of inverse operations, the inverse operation of addition is subtraction. So we're going to subtract 9 from the left side, resulting in x on the left-hand side of this inequality. But what we do to one side of an inequality, we have to do to the other. So we need to subtract 9 from both sides. We get negative 21 on the right side. And when we add or subtract across an inequality, we do not change the direction of the inequality. So we end up with x less than or equal to negative 21. Graphing this, place negative 21 on our number line, and we'll have a closed circle because negative 21 is included in the solution set. And then it also includes all numbers smaller or less than negative 21. Checking a few points, we will check where the left and right side of the inequality are equal. So at x equal to negative 21, we have negative 21 plus 9 less than or equal to negative 12. This is negative 12 less than or equal to negative 12. In this case, that's a true statement. We'll check another point. In the solution set, we'll check x equal to negative 25. But you can pick any number in this shaded region. So here we have negative 25 plus 9 is less than or equal to negative 12. And this is negative 16 less than or equal to negative 12. Again, another true statement. Our solution is x less than or equal to negative 21. In this second problem, 24 less than negative 8y. In this example, negative 8 is multiplied to our variable. Using inverse operations to solve this inequality, we will undo this multiplication with the inverse of multiplication, which is division. So we will divide this right side by negative 8. So we end up with y on the right side. Again, what we do to one side, we have to do to the other to keep the inequality balanced. So we'll divide the left side by negative 8 as well. This is negative 3. And when we divide by a negative, we have to switch the direction of the inequality. Next, I'm going to rewrite this inequality with the variable on the left side. So we have y less than negative 3. Graphing this inequality, put negative 3 on our number line. This is an open circle because negative 3 is not included in the solution. We have y less than negative 3. We will shade everything less than or smaller than negative 3. So any number less than negative 3 is a solution to this inequality. I'll again check at equality. I will check to see where both sides are equal to each other to verify we found the correct boundary or edge of our inequality. Y equal to negative 3 is not a part of the solution, and I will check this as equality. I'm going to change this to an equal sign because I'm just verifying that I found the point where the two sides are equal to each other. So we have 24 equal to negative 8 times negative 3. So this is 24 equal to 24. So yes, we correctly found the edge of our inequality, the boundary of that inequality, but it is not a part of the solution. And we'll pick another point. Let's go with negative 6. So at y equal to negative 6, we have 24 less than negative 8 times negative 6. So this is 24 less than positive 48. And that's a true statement. This is our solution to the inequality. For the previous two problems, I solved those inequalities using inverse operations. For these two, let's solve using the properties of either addition or multiplication. So for this third problem, we have x divided by 3. And we can rewrite this as 1/3 times x. So we have the coefficient 1/3 in front of our x. And then this is greater than -12. Now the goal here is to get x all by itself on one side with a coefficient of 1. How do we convert 1/3 to 1? Well, we multiply it by its multiplicative inverse, or its reciprocal. So the reciprocal of 1/3 is 3. So we're going to multiply 1/3 times 3, and this is 1. So we now have 1x. And again, we could just write that as x. But just like before, we multiplied the left side by 3 in order to convert the coefficient to 1. So therefore, we need to multiply the other side by 3 as well. We have to keep the inequality balanced. So now we have -36 on the right side. We multiplied by 3, that's a positive number, so there's no change in the direction of the inequality. So the single step was the same. We multiplied both sides by 3. We would have done the same thing if we did this using inverse operations. Graphing, we'll place -36 on our number line. It is an open circle. -36 is not a solution. And x is greater than -36, so we're going to shade the number line greater than -36. So all of these numbers greater than -36 are a solution to this inequality. Checking the results, I'll again start with equality, where the two sides are equal. So we have x equal to -36. Again, this is not a part of our solution. If we plug this into our inequality, we get -36 divided by 3, and then greater than -12. So this is -12 greater than -12. Again, that's not a true statement, but it is where the two sides are equal, and that is the boundary of our inequality. And let's check another point. Let's go with -33. So at x equal to -33, we have -33 divided by 3 greater than -12. -33 divided by 3, that's -11, greater than -12. And that's a true statement. Our solution is all numbers greater than -36. Using the properties of addition to solve this fourth problem, I will rewrite this using addition. So we have y plus a -13, because subtraction is the addition of a negative. So to go from y plus a -13 to y plus 0, we need to add the additive inverse, or the opposite of -13. And the opposite of -13 is positive 13. So we'll add 13 to the left side. And what we do to one side, we have to do to the other. So we'll add 13 to the opposite side. -13 plus 13, that's 0. So we have y on the left. That's -9 on the right side. We added across the inequality, so there'll be no change in the direction of the inequality. So we have y less than or equal to -9. We'll place -9 on our number line. We have a closed circle because -9 is included. And we will shade to the left, or smaller than -9. We'll check at equality first. So at y equal to -9, We have negative 9 minus 13 less than or equal to negative 22. And then this is negative 22 less than or equal to negative 22. So this is a true statement. Negative 22 is equal to negative 22. And let's try a second point. We'll do y equal to negative 13. So we have negative 13 minus 13 less than or equal to negative 22. This is negative 26 less than or equal to negative 22. That's a true statement. And I solved this using properties of addition. So I added the additive inverse, or the opposite of negative 13, and that resulted in a 0. And when we add 0 to y, we get y. But again, the step is identical to what we would have done using inverse operations. So we subtract 13. The one step we perform is we add 13. So as we solve one-step inequalities, that one step is when we multiply both sides by a number, or when we add a number to both sides. That is the one step that we're talking about, when we do something to both sides of the inequality, or both sides of an equation, like we saw in the previous unit. But you may have to do more than one thing. So when we solve inequalities, just like when we solved equations, we want to simplify down each side as much as possible first. And we simplify down a side by combining like terms. In this fifth problem, we have 5x and negative 4x. These are like terms, and we can combine them. 5x minus 4x is x. So now we have x plus 3 greater than or equal to negative 1. I will again solve this using inverse operations. 3 is added to our variable. So to undo that addition, I will subtract 3. And then what we do to one side, we have to do the other. So we'll subtract 3 from both sides, resulting in x and then negative 4 on the right side. There's no change in the direction of the inequality with addition or subtraction. So we end up with x greater than or equal to negative 4. So we'll place negative 4 on our number line. This is a closed circle. Negative 4 is a solution to this inequality. And x is greater than negative 4, so we're going to shade everything to the right are greater than negative 4. Checking the solution, I will start at equality, where our point is. So at x equal to negative 4, now this is a part of the solution. So we should get a true statement when we plug x equal to negative 4 back into the original inequality before any simplification was done. And we do that in case we made a mistake simplifying. So we have 5 times negative 4 plus 3 minus 4 times negative 4 greater than or equal to negative 1. So this is negative 20 plus 3. We have negative 4 times a negative 4, so this is plus 16. Greater than or equal to negative 1. We get negative 1 greater than or equal to negative 1. Picking another point, we'll go with 0. So at x equal to 0, we have 5 times 0 plus 3 minus 4 times 0 greater than or equal to negative 1. So this is 0 plus 3 minus 0 greater than or equal to negative 1. So 3 greater than or equal to negative 1. That's a true statement. The solution is x greater than or equal to negative 4. For this last problem, the first step again is combining like terms. And we have like terms on both the left side and the right side. On the left side, we have 2y and 5y. These are like terms. And this is negative 3y. 17 minus 2 is 15. We're now ready to perform that one step to solve the inequality. Negative 3 times y. So to undo multiplication of negative 3, we're going to divide both sides by negative 3. Negative 3 divided by negative 3 is 1. They cancel each other out. We have 1y, or y. 15 divided by negative 3 is negative 5. When we multiply or divide both sides of the inequality by a negative number, we have to change the direction of the inequality symbol. We'll graph this, place negative 5 on our number line. It's an open circle. It's not included in the solution. And we will shade everything to the right, everything greater than negative 5. Let's check this answer. Again, we will start at equality, where the two sides are equal. This should not give us a true statement, but we should get the same value on both sides. So at y equal to negative 5, we have 2 times negative 5 minus 5 times negative 5 less than 17 minus 2. So this is negative 10 plus 25 less than 15. We get 15 less than 15. Again, this is not true because y equal to negative 5 is not included in the solution. We'll also try 0. At y equal to 0, we have 2 times 0 minus 5 times 0 less than 17 minus 2. You get 0 minus 0 less than 15, and 0 is less than 15. So that's a true statement. The solution is y greater than negative 5. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. $12 is subtracted from our variable a. So to undo subtraction, we will add 12 to both sides, resulting in a greater than 5. For the second problem, we have b divided by negative 7. And we'll keep the negative with the number. So when you see negative b divided by 7, you want to view this as the variable b all over negative 7. So to undo this division by negative 7, we multiply by negative 7. And since we multiplied by a negative number, we will reverse the direction of the inequality, resulting in b less than negative 35. In this third problem, we'll combine like terms on the left first. We can simplify that down to 15c. We have 15 times c, so to undo this multiplication by 15, divide both sides by 15, resulting in c greater than 3. And then finally, 7 is subtracted from the variable d. To undo subtraction, we'll add 7 to both sides. We end up with negative 4 greater than or equal to d. And then we'll rewrite this so that the variable is on the left side of the inequality. We have d less than or equal to negative 4. Continue practicing solving inequalities, and I'll see you in the next video.